Hello everyone, my name is Joe Squarzone, channel's called Ethernet Wing. In today's video, you can tell by the lights, we're doing C++ again. The last video did super well, and it's been growing the channel a lot, which thank you for that. We're almost at 300 subscribers, which is awesome. When I get to 1,000, I start making money, so that'd be sick. But the last video is just a different flavor of this one. I didn't even notice that we're just on, not just on me, so there we go. It's just a different flavor of this one. As you can tell by the title, this video is pricing options and calculating the Greeks using the Black Scholes model. Last video, we used Monte Carlo simulation to calculate option premium. And we didn't talk about the Greeks or implied volatility or intrinsic value at all. Actually, we talked about intrinsic value a little bit. I want to record this video in a way that if you didn't watch the last video at all, you can still follow along. I encourage you to watch the last video. That was a great video. I enjoyed making it. People enjoyed it, so maybe you will as well. Today is pretty much just a different flavor of that same concept, pricing options. And so now we're going to price options using the Black Scholes model. And of course, all the links to this stuff is going to be in the description. I have a lot of links for this. And so, yeah, the first thing I'm going to do is I'm going to show you guys my ChatGPT conversation I had. Because instead of sifting through a million links, even though I have links for you guys, I just had a conversation with ChatGPT. What is the Black Scholes model for calls and puts? Here we go. Here's all the equations you would ever need. What are the formulas to calculate the Greeks on calls and puts? Here you go. All the information you would need for it. How do you calculate implied volatility and intrinsic value? Right here. What do the Greeks represent? Right there. All that good stuff. So the next thing I want to do is, oh wait, no, just here, boom. Visualize Black Scholes model a little bit. I love finding things like this. I pretty much just want to show you guys at first how much option value would get affected by changes in the parameters. So the black line would be the option value for calls or puts up here. And so you can see that if we change the risk-free rate, it doesn't really change the option value much. I'm just going to leave this at 0.3. If we change the volatility, changes it more. This is where value is like either made or just dies. Not that. There we go. Expiration changes it quite a bit. And then we also see that the spot price relative to the strike price, however you move the value around, changes it so much more than the other ones. So that's why we trade options, really. Just because we want to see this huge change in price, all this value occur, just because they're options and the way that we calculate their value. So, with that being said, with that little visualization of how these different things affect the prices of options, let's get into some code. So, I'm going to explain these two functions first because they're just here. I didn't even write them. I found these online. Again, link to that will be in the description. I just found that on Stack Overflow. It's just the cumulative standard normal distribution, just that density function for that. And you can just calculate it through this. It's because we need a normal distribution for our calculation. So we just had that function there for that. Now, in C++, you can't return more than one value in a function. So how do we return the contract and all of the Greeks and implied volatility and intrinsic value? That's a lot of parameters. Well, not really. Because we can just use a class, or struct technically, but a class. So up here, we have our contract. It has all of these attributes: premium, DTE, delta, gamma, theta, vega, rho, implied volatility, and intrinsic value. I'm not a frat guy, by the way. I just look at options a lot. But, so, when we make a contract, so when we call our function, and we make a contract con, we can then say con dot whatever, and set the value to be whatever we want it to be. So, because we want to know our days till expiration, and we send the value in years, we would say t times, and then this, and then we would get our value. Now, this function also returns of type contract of type up here. This is done so that way we can actually use our class and we're not just making it for nothing. And also that's why I have auto down here. I can use contract, but auto is just cooler in my opinion. So let's go through now and actually calculate this. So it is a different formula if it's a call option or a put option. So that's what this check is. These first derivatives are the same for each contract, call or put, but whatever. We still just have them in here. You could just calculate it in the top, but it doesn't really matter, I suppose. It's not different if you take this out of the if analysis, is what I'm trying to say. But I think it'd honestly be better if I show you guys the actual formula like here, because it's not any, like, the concept isn't super cool like in a Monte Carlo simulation in my last video, and I don't want to spend too much time going over it because there's cooler concepts I want to go over in this video. But it's simply a formula, and so we're actually going to go over, I'd rather go over like the fundamentals of C, where I can say con dot premium and it just equals this equation, because it really is just a bunch of math, right? Just all, that's the first derivative, that's the second derivative, this is premium, right? Like, I'm not head of risk at State Street, so I'm not entirely concerned about what this formula does at this point in time. Maybe at some point it'll be more apparent. I hope for a day like that. But I'd rather talk about the fundamentals in this program, or in this video, because I feel like going over just the nitty-gritty parts of that, it'll just be easy to get lost in the sauce. So just simply, these are the formulas, and this is our option premium. That's how much the option costs. Now, Joe, what do you mean option and premium? The stock costs $100. Yes, you're absolutely right. And I put beginner friendly in the title, which is why I'm going over this. What is an option? An option is the right, but not the obligation, to buy or sell, depending on call or put, 100 shares of a specific stock at a certain price before a certain date, because you can exercise early, before or on a certain date. Now, if I buy an option for $100 or $1, because that's how options are priced. When you see option premium and it says $1, it's really a $100 option. That's how much you actually pay for it. So now that doesn't make sense. That doesn't make much sense because of opportunity cost. Well, it does, but you know what I mean. Like, you want leverage, which is why you'll pay $200 for an option contract when the stock is trading $100. You can only get 2 shares for $200, but you can get an option contract that represents 100 shares, for the same price. That's why options are an attractive price. But so now, if I have an option, if I have a call, and we're trading at $100, my strike price is $100, and all of a sudden my stock price goes to 110. Well, now I have the right to buy something that's trading at 110 for 100. That's awesome. That's why values and options go so crazy. And for the opposite, puts, it would be like that, because puts make money as the stock goes down in value. Little overview about options if you didn't know. Now, again, I think it would be super chewy for me to go over these specific equations, because I doubt that they would really mean something to somebody, like why it's so revolutionary. But so I just kind of wanted to go over the concept of using a struct like this, how to calculate premium, in the sense of this is how to do it, and what represents the cost of the option relative to, like, the fact that it is a contract, and then, you know, explaining how you make money on these things. And then let's talk about Greeks a little bit. So delta is, it'll actually be a little bit easier if I just run the program. So delta, this value of 0.63, that represents how much the options premium will change per dollar change in the stock. So all of a sudden, if this goes to 101, our options value should change to $11.03. That makes sense, because we have that's right here. Delta also represents kind of like a probability of how likely it is for an option to expire with the stock price greater than the strike price. In the money is what we call that. This contract is out of the money. This contract is in the money. This contract is at the money. Intuitive. That's what that represents. We're going to get more into expiration a little bit later on when we get to theta. Gamma represents delta's rate of change relative to changes in the price of the stock. Gamma is always a lower value, like this, super small. Theta represents time decay. What's time decay? Well, options expire. In this case, there's 365 days till expiration, but options expire. So what happens if when an option expires, if our stock price, if we're in the money, so our stock price is greater than our strike price, and it expires in our account, we then get what's called exercise. So we buy 100 shares at $110. Okay? And when the stock is we buy 100 shares at $100 when the stock is trading at 110. So that's why that's good. If it's not in the money, if it's out of the money, even just by $1, even just by $1.01, right? That's called out of the money. So this option expires worthless. It's worth 0. How does it go to 0? Well, because of theta, right? Theta is your time decay every day that your option is out of the money. Options are designed to go to 0. They're not supposed to make you money in reality. Why do we still trade them then? Because like anything, there's a risk. And if you manage the risk well, they can be incredible tools. Vega. Vega represents the change in option premium based on the rate of change of the option premium, like how sensitive option premium is to the stock price's volatility. Right? So if this is just going crazy and volatility is picking up, regardless of what direction, your option will gain some value from that. Of course, if it's going in the wrong direction, you'll still lose money. But there is that aspect to it of volatility giving your option premium. And then rho, nobody really talks about rho. Nobody really cares about poor little old rho, but it represents how sensitive the option premium is to the risk-free rate. Why does nobody care about rho? Because the risk-free rate doesn't change at an incredibly fast rate, so it doesn't really have a big effect on our options. Implied volatility is like what it sounds like. It's implied volatility. How volatile is this option a little bit? Let's even go to this, because I did kind of cheat a little bit in the way that I calculated implied volatility. We'll calculate that. So implied volatility is a volatility value that, when input into an option pricing model, gives a theoretical option price equal to the current market price of the option. There's no closed form formula for calculating implied volatility. Instead, it's found using numerical methods such as Newton-Raphson iteration. The general steps to find implied volatility are as follows, and I'll show you where I cheated. Initial guess. Start with initial guess for volatility. Use the guess volatility in the Black Scholes formula to create the theoretical option price. Compare the theoretical option price to the market price, and adjust your guess and get closer to that, and then repeat. So where did I cheat? Well, I don't technically have a market to compare this to, so I just kind of skipped ahead in that whole iteration process, and I'm just using numbers that are really close. So I'm using the option premium minus a cent, the actual option premium minus the option premium minus a cent, and then over Vega, and then sigma minus. That's how you calculate implied volatility. Instead of iterating through and getting super, super, super close, I just kind of got close. But that makes sense though, because if I price an option at $70, but the market's trading it at 100, that option is overvalued, right? Regardless of anything else. And it could be because of implied volatility. It could be because of a lot of things. So when you actually calculate an option's price with all these things, with your guesses of volatility, and it's off from actual market price, the market could be mispricing the option. It could be worth more or less, ideally, than what it is worth. That is a whole section of quantitative finance, is trying to price options and find out when options are mispriced. it's sort of like the best trade, because even if you lose money on that trade, it's not a bad trade. If something is trading for 25 cents and it's worth 50 cents, I don't care what it is, what direction it's going to go. Give me a few, at least. I want a little bit of that. Because worst case, I lose money on it. I lose 25 cents, it expires worthless. And best case, or base case, the option market just reprices it. And best case, it reprices it and it goes further. Right? That's where people make stupid money. Stupid money, because it doesn't show up a lot. You might not always catch it, but when you do catch it, it's such a good risk to reward. And then intrinsic value. Intrinsic value, I kind of went over a little bit, kind of. If I have a call and the stock price is $10 more than my strike price, that option has $10 of intrinsic value. For puts, this option has $10 of intrinsic value. But yeah, now that I've explained all that, and you guys have at least looked at the code for it, that's the video, really. That's how to price everything. I didn't really want to go into the nitty-gritty of the math, because it's simply an equation. You know what I mean? Like, I'm not doing anything wild. I'm just doing an equation like I would in a calculator, but I'm just using variables. Like, I think you're smart enough, even though I did write beginner friendly, I think you're smart enough to understand that this is just aligned math, right? I'm giving you credit there. I will explain an option contract to you every video. But when I'm just doing math, like, you've calculated tips before, you know what I mean? You know how to multiply, I'm sure. I'm giving you credit there. But something I want to do as well is, because I'm actually going to recompile this to make sure I'm at 100 and 100. I'm going to make sure over here I'm at 100 and 100. Cool. I'm at the same risk-free rate and volatility and expiration. All right. I want to compare the Black Scholes model pricing to the Monte Carlo pricing that we did in the last video. We can see that the Monte Carlo simulation prices these options at 42 cents higher, technically 43 cents higher than the Black Scholes model, and the puts being 26 cents higher. Really, really interesting. Who's right? Nobody knows, right? It's kind of like they're both right in their own regards, and then the market will price them in the sense of how much is someone willing to pay for them. Because if you believe that these options are worth $10.87, and you see the Black Scholes model price it at $10.45, you'll call someone up. You'll go on and see who's selling these options at Black Scholes model value, and you'll buy at least two. You'll buy at least a handful of them, because you believe from your option pricing value that these are undervalued. Do you see the game of option pricing? It's such a chewy, weird topic. There really is no way to know that you're right, because regardless of if I can price the perfect option, but the market just misrepresents it, it's all washed away. It doesn't matter. I would know not to trade it. There's that aspect of it, but market could still exacerbate it. But I hope that you guys enjoyed this video. These videos are so much fun for me to make. I love talking about options and pricing things. I'm a total nerd when it comes to it. And I just think it's crazy that we still use the Black Scholes model, because there are other option models, which is bringing me into what I'm going to make my next videos on. The next thing I want to make a video on, we're actually going to go in little steps. So this is going to be a little mini series of pricing options in C++, because we have this Monte Carlo simulation. And if you can notice, I don't calculate the Greeks on the Monte Carlo simulation, because there's no derivatives in this one. See how in this equation I have D1 and D2, and I use that to calculate the values? In the Monte Carlo simulation, I have no derivatives to use. It's just this straight up equation with the Gaussian noise, and then it converges to a value. That doesn't exist. The Greeks don't exist in the Monte Carlo simulation. Derivatives don't exist in the Monte Carlo simulation. I am not sure if Greeks do. That could be something for me to look into. But as of right now, what is definite, I want to continue this specific file at least, so that way I can calculate an entire option chain, like 5 or so strikes in either direction. And I want to make the Heston option model because it uses a stochastic volatility that changes over time, which is awesome. And I want to look into volatility surfaces. I want to represent this somehow in C++. I'm probably not going to plot it just because I don't think that C++ has great plotting libraries, but I'll just make a matrix. You know what I mean? Just a vector of vectors and somehow model this numerically. But that's it now. That's pretty much it. You guys get the rundown for option pricing and greed calculation in the Black Scholes model. Have some plans. Yeah, I don't want this video to get much longer. I don't think it needs to be longer than the Monte Carlo one. But in the description, there's a ton of resources. There's this code, more stuff, more references. I use my ChatGPT conversation. I didn't know that I could link them. So I'm going to link this one. There's also going to be links to my personal Twitter, to my business. Please check it out. We make cool stuff. And yeah, I hope that you guys enjoyed this video. My name is Joe Scorsone. Channel is called Ethernet Wing. Be sure to tune in later on for those videos that I mentioned I would do. And yeah, have a good day. I'll see you in the next one.